And we're back for one last time.
One last session.
Now, for the folks who've stayed with us the whole day, one, thank you. I know that for us, to deliver this, it's somewhat of an endurance test. My heart goes out to teachers everywhere that stand and teach, like from 7:30 in the morning till 3:30 in the afternoon every single day, because it is always challenging to be on for that amount of time. But most of all, I wanted to thank everybody who's been listening all day, because listening to me and Jeff for 7 hours or whatever it's been is also a challenge of its own kind. So thank you for sticking with us. And for folks who just tuned in, a lot of the other interesting topics that we covered today are going to be available online later. For example, well, actually, let me just go through those for a second. Yeah. So we started off today, we did, the overview of Windows 8.1. So, we talked about what is Windows 8.1 and why you should be interested in that, as well as, the kind of hello simple apps in XAML, as well as HTML.
How to get started with an app, just the very basics of it.
And then we did a little bit of WebGL. And
well, we talked about HTML for app development. We started out talking about the web and some of the cool new features in 8.1, in this case, IE 11.
Yep.
WebGL was a big one of them, being able to do the 3D directly in the browser. And then we talked about HTML5 apps and bringing those features like WebGL into the app space and being able to use them as an app, and then how to take that a step further and use some of the WinRT APIs inside
the
app
web app
HTML.
template that you did. Yes, right.
And then next, after that, we talked about the web app template and how you can start from scratch to bring your web app into the Windows Store, or use the web app template as a starter to turn your web app into a Windows Store app.
Okay. And then we had lunch. I hope everybody had an enjoyable lunch. And then after, or supper, or midnight snack, or whatever it may have been for you. And then we did a little bit with speech and the camera and the microphone. So we had an interesting silent speech demo here, but you'll be able to download the source code and try it yourself. But our totally incompetent camera crew in the back couldn't make the audio come through. We'll, because that's what it was. It was not a bug in my code, I'm positive. Weren't able to get the audio out of that, but still we showed how to use speech. We showed some webcam stuff. You had a cool thing with the Eddie Bowl.
Yeah, the device APIs are really exciting to me, because being a web developer for years, working in this space where you don't have access to things like USB and the sensors in the media inputs on a device, being able then to have being in the app space and have access to those things can really take your web apps to another level and enrich them.
Right. And then we also did some 3D printing stuff, and I think we did something cool here. We live 3D printed something that finished up, and it went missing, but we seem to have found it.
Yeah, I somehow got it in my bag.
Yeah, I had no idea how that got in your bag.
But this is what we ended up with, and then obviously the wheels printed as well. So I think this is really interesting. It only took 2 hours?
Yeah, it was pretty short.
So this is what it looks like. In this particular one, it comes off the printer just about ready. One thing that there are here that you'll see is a little bit of support plastic that I'm going to pull off. And the support plastic is what it uses to fill the gaps whenever it can't print straight across.
If you're building a bridge, printing, the way that this thing works, it lays out the material horizontally. Yep. And so you have to have something underneath to support what you're going to be printing. Some printers will actually print that in a different material that can be dissolved by water or dissolved by alcohol or something. And other printers, what they do is like this here, which is a very, they do a lighter weight mesh of support material there, where it's made so it'll really peel away quite nicely.
Yeah.
And so you see the wheels are snapping on. Yep. Cool. Jeff gets toys.
I do. Finished product.
The other thing that we had here is we brought some demo stuff. So here was the key. What was the key called? The key of something or other. Like wasn't this the key that he used to get into
to the mountain?
Yeah, to get into the mountain. So this is some cool kind of hobbity stuff here. So that was a cool little thing. We didn't print this live, but it was. Watch the 3D printing video. You'll see there's some really cool close-ups of this that give you an idea of the level of detail. So let's see the train.
Train.
Does it run? Does it work on the track behind you?
Let's see here.
Oh, here, let's hold it. Can you bring the track over? Here, yep. We'll do this. Understand that what we just did is we made a toy. Like
Right.
over the course of the day here, we made a toy, and anybody here who has children or just happens to like toys, that's kind of a big deal. Like if your kid says, wow, I really wished I had an action figure that did this, and you can be superhero and create an action figure that does that. It's also a great way to say that the computer time and toy time you're doing is actually for your children and not for you, right? So here, you want the honor since you were the one stealing it. So let's see, do we have? There we are. Yay. Can you make the Thomas sound? Can you go toot toot? Yeah. And there you go. Oh, and we did the branding thing again. Sorry, guys, but so Sir Topham Hatt's going to come over and arrest us. All right, so we did that. So that was, I think that was one of the more exciting things today. I loved the stuff with 3D printing. Also, you weren't on it, so I didn't have to deal with all the crap from you I get all the time. We had Chris Iverson from the team, which was really cool. After that, we talked about USB and Lego, and we had Eric Haver over for that. And we had this cool Lego robot arm, which we were able to control over USB. And we didn't show it in a demo, but over there you have the Bluetooth robot, right? So being able to use Lego stuff over Bluetooth, very, very cool. We have folks here at Microsoft who've got a pretty good relationship with the people at Lego and have been working with them to make these things work. So I've been very excited to see that happen. Again, more toys. That seems to be somewhat the theme of the day is toys. Then we did some Bluetooth stuff. So we had the little Sphero here. So, excuse me. So here's a little Sphero, which is that ball that, this is going to be loud. There we go. It's like cracking an egg, so now it's like sort of ready, it's blinking, it's ready, waiting for something to connect to it. And we're controlling that from a surface. So again, kind of very cool stuff. And I'm going to sit it has a wireless charger, which I always like those wireless chargers. I just sit it in that and it'll charge. And then we also did that Dagu race car. So that was something else where we showed Bluetooth code to connect to this little $30 race car that you can get over at SparkFun, probably some other places as well. But for $30, there's like no excuse not to. If this stuff is even remotely interesting to you, I really think that was a cool project to show as well. Then we talked about Windows Embedded. So, the whole idea that, ATMs and kiosks and digital signage and all these things, many of them are running Windows Embedded. Many of the types of projects that we build probably should be running Windows Embedded. So you can do things like, I mentioned crash recovery in case something happens, something catastrophic, automatic rebooting, suppression of dialogues, just like simple Windows update stuff. That dialogue that I showed from the photo that I took at Dulles Airport was of the screen saying that update is complete, time to reboot. So having all those things automatically done for you as part of Windows Embedded are a pretty big deal. And then we won't show them now, but I also had over there some Windows compact devices. So if you're building smaller things like industrial controllers or stuff that need real-time operating systems, we have some of that. And I also talked a bit about Windows Embedded handheld. So some really kind of interesting topics there as well. And if you're interested in seeing some of the Windows Embedded industry machines, we had a demo at Build. It was Stephen Guggenheimer's demo. He showed some Avis PCs and what they were running an Avis app on them. It's okay for us to talk about that. They're running some Avis apps on those. And they were tablets that are in a special kind of sleeve that provided access to a card swipe as well as a scanner so they can scan the stuff. Yeah. So again, really, really kind of cool stuff there. And then after that, we did a little bit with the barcode scanner here. And I realized afterwards that you'd probably stolen the shirt that you're wearing because it still had the tag on it. And, hopefully you don't, let the ink tag out later on. And just, it's like, and that'd be the end of that. And I'm sure I just peeked over there again, so sorry, guys. And then we're messing with lasers. And like I said, if it's not interesting enough to you as just a straight barcode device, it'd be kind of a cool phaser. Stand-in thing, right? So for all the Star Trek folks out there. Although the hardcore Star Trek guys are going to be pointing out to me how unsuitable this is for a phaser. But anyway. All right. So what we wanted to do here as our last session, we wanted to do a little bit of recap. But at the same time, we wanted to offer some additional value because who wants to watch a recap session? Nobody's going to watch a recap session. So to get you folks interested in seeing this last thing that we're doing today, we wanted to talk a little bit about performance. And performance is something that despite the fact that we're leaving it to the very end, a lot of developers, honestly, they leave it too far to the end. I mean, you think about some apps that you've seen and helped with. Yeah,
it's always a shame whenever you have a really great idea idea and a concept and you get it running well in an emulator or on your x86 device, and then you port it onto ARM and it's a mess. And you know, sometimes it can take your development back to square one.
Yep. I mean, my PC at home is a beast. It's water cooled, overclocked.
Yep.
You know, 6 cores. I've got, you know, a lot of, you know, 2 video cards, a 4K display. That is not, and I just wanted to get that all out on camera, by the way. It's not your typical end user machine.
Yeah.
So I bought some very inexpensive laptops for my kids for Christmas this year, because when you're 5 years old, you don't want to get them an Ultrabook necessarily, because that 5-year-old is going to be sort of rough on that device. But they're still touchscreen Windows 8.1 devices, but they were noticeably slower than like my wife's Acer, right? And so, you know, testing on these different kind of different performance devices is very important. But not everybody has access to all the different types of profiles. So what we are going to talk about here are 2 things, or 3 things. One is just some general tips and techniques for XAML performance, some just things that you should be looking at. Some stuff for HTML and JavaScript, right? We have some few things there. We don't have slides for that, but we want to talk about it. And then just a little bit, perhaps as part of that, talk about some of the tools that are built into Visual Studio that'll help you figure out how to do this without having to go and like beat up your grandmother and take her low-powered laptop and use it to you know, run and test your app, right? So cool. So I'm going to jump right in here to some XAML stuff, because that's what I do. If you're looking at binding performance in XAML, so I like MVVM as a pattern. I like data binding and stuff as well, but I do know that there can be a performance cost to that. And the default binding in XAML is one way. And if you think about how that works, that means that the UI will always be looking for updates from the you know, the underlying objects, and there's a cost associated to starting that up and building that infrastructure out. So one way means that the item may be updated again, but for most apps are, you know, get the data out there, and then a lot of times it's not updated again. Like a lot of the data is pretty static for that run of the application or for the lifetime of that screen. So in that way, if you use one-time binding instead of one-way binding, and you have to specify this in the binding statement, because again, it's not default here. But if you specify one-time binding, it'll be updated once, and then we don't have to build out all that other infrastructure to monitor this. And so that will help the performance of the app. A very simple change you can make. You know, don't go and rewrite your entire app at this point to do this, but keep it in mind for places where there could be a little more performance, or apps that you've been working on that maybe aren't running as quickly on low-power devices, and not just ARM, but also low-power x86 device. You know, think about those and take a look at those devices, and also take a look at your binding code in there. Delay loading your resources. So there are 2 schools of thought when it comes to resource loading. And you have similar things in HTML, I'm sure, as well, where the choice is you can take and load every last thing up front by putting all your resources in resource dictionaries referenced from app.xaml. And that will impact the startup time of your app, because it has to go and parse through all of that, has to you know, load all of those, takes up the memory associated with them, etc. If there are resources that aren't used in every single screen of your app in a very large system or something, then you'll want to have those merged in as resource dictionaries at the page level, or at the sub, you know, wherever it is appropriate on that page. That way they only get loaded into memory when those, you know, when those pages are loaded up. Right, so this is like you do some things in HTML with images,
right?
Like that, right?
So in HTML, we actually have a little bit of a different pattern when we're working on the web. A lot of times we'll load images as a matrix, as one big file that has all of our images in it, to reduce the number of connections we need to make on the server. The downside to that is every time you're using a portion of that image, you're taking up the memory footprint for the whole sprite.
Right.
So when you have those resources locally, like you often do in a store app, because it's already been downloaded once from the store, making an image matrix is not really the best idea. You want to use the smallest, lightest images that you can for memory consumption reasons, not about compression, about actual memory usage.
But that's actually a really good point, because when folks think about memory usage for images, they look at the size of the image on disk, but that's not really, even on XAML, that's not the case.
That's right. It has nothing to do, it's not even as relative as you would think. It's about what it's utilizing in the app. So you want to cut that down as much as possible so that you have memory to run JavaScript and app functionality. The best idea is, again, to load resources when you need them, and not beforehand.
Yeah, and the image thing is interesting because what it is highly related to is the resolution, because when these images are loaded in, they are decompressed and they are loaded in bitmaps.
Yep.
And at least in XAML, what you typically end up with, depending upon how you load the image, which I don't recall if I have that in here, but it's something else that I know Tim has discussed with me, Tim Hewer has discussed with me a bunch of times. If you load that image at its native resolution and then resize it, you're actually saving memory for that big image, even though you're only sort of displaying it at this size, right? So there's sort of the size on screen, the size that you're loading, and other stuff. Oh, as a matter of fact, I do have it in here, so very good. So when you're loading an image in XAML, there are a couple of different ways you can do it. So you can load up the image, and let's, for grins, let's say that this is a modern image that, you want to make sure it supports high DPI devices, and you want it to be, a pretty high resolution image. Well, you might load it in as, let's say it's a width of 400. And if the image is 2048 by something else, you're still taking up all the memory associated with that size. Instead, what you can do is specify a image source that has a decode pixel size associated with it. So there's a width and a height. Ideally, you should specify both, but if you're trying to maintain aspect ratio and you don't know both dimensions, you can specify just one of them anyway, right? Because that's the other thing that drives me nuts on the web is when I see images that are not at their proper aspect ratio, it drives me batty.
Yes.
And folks don't realize that. You'll see images of people and they're stretched out. And I blame HDTV for that.
We've gotten accustomed
we've gotten used to seeing everybody on the screen like stretched out wide because we're watching SD content on HDTV. So if you take this and you decode this at that specific size, you're going to save load time, you're going to save memory, and it's just going to work more smoothly for you. And there's a way you can do this from code as well, so it doesn't have to be just that way in XAML. Okay, good. So the next topic I wanted to talk about is direct from build. I would very highly encourage folks to watch the grid view performance talk that's at build, because that's something that the XAML team spent a lot of time trying to optimize. So, if you think about an unnamed movie rental type online company that may have thousands and thousands of videos that you have to scroll through, you have to scroll through those, and if you scroll through quickly, you start to notice things aren't painting. Excuse me. You're starting to get that black screen, like where you've gone way past what the app is able to keep up with, and then you see them start to come in afterwards, right? And the problem with that is it's because we're using data binding to populate all these data templates in XAML on that. You are getting, it has to load all the stuff that's nearby on there. So that, the way the caching works, it has to load the different groups and stuff on there. It's loading all that content that's nearby, and it's having to do a complete build on each one of those data templates. So if you have an image and a label and maybe like a release date and some other stuff, it has to build all of that before it goes on to the next one. So let me, it's good to watch that talk there. So we're dealing with that two different ways. One is that we have updated UI virtualization, so it doesn't have to build out so much of the stuff around it. So in 8.1, you'll get that for free if you use our built-in panels and built-in grids and stuff like that. So that'll automatically come for free. And the other thing that we did, which I'll talk about in a second, is to make it so we can incrementally update that content.
And likewise in HTML, scrolling lists are always a problem because you're always adding to it, adding more elements into the DOM, using more images. One of the things that I do recommend, especially with those type of lists, is the WinJS 2.0 that was introduced in 8.1. They have a significant performance improvement from the past. So if you're using WinJS and you have an 8.0 app, that alone is a great reason to upgrade to 8.1 and bring in WinJS 2.0.
Yeah. And I mean, the product teams have spent a lot of time trying to, perfect those performance areas because, we use it on the start page. We want to make sure that as you get more and more apps on there, that performs really well. But again, these apps that list lots and lots of items like that company that does the movie stuff, you want to make sure that you have a good experience going across that. Now, a little caveat about virtualization. In order to virtualize the containers and stuff that we're using, they need to all be the same size. So you can't virtualize things that are variable size because we can't reuse anything there. So keep that in mind when you're designing the UI. If you're dealing with thousands of elements or lots of things that are going to be displayed on screen, try to keep them all the same size. You'll get the best performance out of that. So large list performance was something that I was starting to talk about a little bit here. But let's look at what you get when you're building something like a grid view item. So the typical amount of Chrome and everything that you see here has the little check marks for selection. It has the usual data template also has a label and stuff down there at the bottom. But maybe what you really need is a subset of that. You don't need all the stuff in the middle. So what you can do is use this new grid view item presenter, which is a class that we have created. Now what this does is instead of you having to have a tree of XAML elements to represent all of the different kind of Chrome that goes around the list view items, we paint that using lower level functions, right? Now that is not quite as flexible as using your own data templates, but at the same time it's going to perform a whole lot better because the deeper your tree in XAML, and same thing in HTML, the deeper that your tree is, like we talked about nested divs once you get beyond a certain point of those, you start to see some performance degradation as well. So same thing here, the more elements that you have, the worse it's going to perform. So in this case, we have the grid view item presenter. It has properties for things like the selection check mark, the background, and the border thickness, and you're able to, excuse me, let me go back. You're able to use all those different properties rather than creating the elements. Now, the thing with XAML is it is very flexible. We want to make sure we maintain that flexibility. So this isn't a required change. It is an additional way for you to be able to present items on a grid view. So you can use this type of functionality rather than the same type of presenter functionality we were before, or you can even mix and match them on the same screen with different grids and all that stuff. We want to make sure we maintain flexibility there. But when you are designing these UIs, consider this. Especially if you don't need selection capability, you might want to just disable that stuff because it is another set of elements that need to be painted on the screen. All right. So the next thing is placeholders, and this is what I was starting to talk about a little bit earlier here, where the idea of incrementally rendering stuff in a grid view can give you really great perceived performance. So we talked about that screen where you're zooming across, and you're smirking every time as I avoid the names of this company. You're zooming across the screen, panning across the screen, and you're not seeing anything. Suddenly you get to that black part of the screen where you don't see anything, and you're like, what's up? And then you see the stuff paint. So it would be more helpful to be able to have placeholders for those items, so at least you see that there are items there, you just don't have them fully painted yet. And bless you to the camera folks in the back there in case that came through. So what incremental rendering does is it lets you control the order in which items are rendered to display the most important pieces. And this is something you do via code. You might think, well, how can I control order of things in XAML? You actually get some an event and some callbacks that you can run through. And again, the build talk on that has really great example of how this is all put together. So take a look at that build talk to see the source code where you can have step 1, step 2, step 3, step n, as many steps as you require to render out that particular content. You can have the placeholder start first, and then you can display just the title, because that might be the most important thing, and then display some other piece of content, and then display like the image that goes behind it, and then display the rest of the Chrome that's involved in that, right? That way you can decide what information is most important to the user to make sure that gets rendered first across the board before we start painting in all the other parts. So again, very, very cool. And again, the number of phases or steps in this it's pretty arbitrary. It's up to you. What you do is you get a callback for each one, and you just keep chaining it until you say you're done. All right? So for example, in this one, we have placeholders first, and then we've got the titles and a subtitle. And then, shortened deck. And then you can paint the other stuff after that. So again, I know I keep referencing it, but definitely check out the build talk on grid view performance, because I think of all the things I think of in XAML that I would want to see people pay attention to, it would be that, because when we're dealing with these large catalogs that we have to pan through and stuff, you definitely want to look at performance for that. Now, do you have any other HTML stuff that you wanted to talk about before we look at tools?
Well, one of the things that we have a benefit of in HTML is the rules are generally the same as they are in the browser. So since it's really a browser component, the rules that we're used to working around with constraints of memory are the same ones that we work with inside the app.
Yeah. So if you're an HTML developer, follow best practices great performance on low power devices, and that'll just carry over as a benefit here. Great. Great.
And if you don't know those,
yes,
there's tools to help.
If you are me and you don't know those, there are tools. So you were going to show a cool demo of one of the tools here.
Yeah. Go ahead.
So let's go ahead and see his screen there.
Okay, so we've used the Yeti Bow app a few times today to demonstrate different things. And what I want to do in this
You're very proud of that app, aren't you?
It's a fun app. What can I say? We're going to run performance and diagnostics tool, and specifically, I want to look at the energy consumption. So
now, these are features that are available in Pro and above, if I remember correctly. So if you are using the free version of Visual Studio, you won't have this. This is something that's
not in Express. Okay. Yeah. So one of the things that bothers me more than anything is when I have an app that I love, many times it's a game or something like that, play for long hours, it just completely drains the battery. So you don't want to be that app. You don't want to be the app that gets removed because you're consuming a lot of battery life and then your user never tries you again. So in this case, I'm going to run the energy consumption app or test on my app.
Yeah. And
then I'm going to just play a little bit just for a few minutes. And
you realize you're getting paid to play a game?
Yes, I am. And then I'm going to stop it and stop profiling.
There you go.
Take a few seconds. And it's actually going to give me feedback on the amount of energy that would have been consumed running my application and doing those same things. So it gives you a good idea of...
So I see, it's measuring milliwatts of energy expended in running your app. Now, I know this is a demo that we've shown like in a keynote before, but it bears repeating because this is a very cool tool. Again, if you're dealing with portable devices, a lot of times folks say, how come low-power devices don't run, desktop apps, or you don't recommend running really big desktop apps? And the reason is they were not designed with energy consumption and stuff in mind.
Right.
And what we're doing is we're at least making it easier so that when you are developing, modern apps for these, that we can profile those to get the energy consumption information out of that.
Yeah.
Yeah. So that's actually a pretty cool thing.
Go right into Visual Studio.
Yeah. And so I've got another. I have a demo here. So this was that kind of silly media capture sample that I did earlier. I think, is this, make sure I have loaded the right one. Not anywhere near as interesting as Yeti Bowl, but it is the one that lets me use the webcam and stuff here. Now, XAML also has access to a lot of the same analyzers, right? So if I go under Analyze, stop Performance and Diagnostics, and I have here, for this particular type of app, I have CPU sampling, so I can see CPU cycles and how that is working. Excuse me, energy consumption, same thing that you saw there, so we can measure energy consumption in XAML apps. And then there's, XAML UI responsiveness. I don't have a whole lot of UI in this app, so it's not going to give me a ton of stuff, but let's try this anyway. So let's hit Start. Yes, I want to allow this to run. All right, and so I can use the PC camera, right? And there's the preview start, video capture, all that stuff. Hello. Hit stop video. That error we talked about earlier, so that's fine. And then I'm going to close this app. I hit stop collection. Now it's stopping. Stop already. Stop.
It's just putting the data together.
Yep. So we're going to see what this is going to come up with in a second here. There we go. That was an interesting scroll bar. It had a little bit of a funky thing to it, right? So what this is letting me know here, if I look down here at the bottom, so it's telling me all the different types of elements here and what are called hot elements, like what's taking time, to process what the user is interacting with. It also shows me up here the UI thread utilization, which for a XAML developer, this is one of the single most useful things you can know, because there have been other talks in the past. I think the previous build, if I remember correctly, not 2013, but 2012, talked about, or possibly 2013, talked about the performance implications for the UI thread in your app. So you may have you may be doing too much on the UI thread, and it's causing the other parts of the rendering system to be unable to keep up. And there are different things that you can look at for like whether or not the screen stutters or it doesn't fill up and stuff to figure out which part of the process is failing. But this will also tell it here where you want your UI thread to have as little code running in it as possible. Don't go nuts and say, Pete said run everything on background threads, because I know some folks do think that way. There is a happy medium here, but we as developers as a whole, and I'm totally guilty of this, run probably too much code on the UI thread where it should be run on other background threads, right?
And that tool might look familiar. Earlier in our sessions today, we talked about the F12 tools in Internet Explorer. That same UI responsive tool that we see for XAML, we also have that for HTML and JavaScript, and we also see that in the browser. So
Right.
It lets you do the same kind of profiling everywhere.
Yeah, and I just think it's wonderful to have this stuff built in and be able to see, I can see the UI thread utilization, I can see the frames per second that I'm getting out of this. Those are two of the most useful tools for the UI that I can get, from these apps. So again, very pleased with this. The Pro version I think doesn't cost very much, so it's in a fairly low SKU here. So it's just, I don't believe it's in the free version. So cool. All right. So any other performance tips you want to share with folks?
I think that's all we got.
Not slides, network. Okay. Well, let me pop up my slide here. I do really want to thank everybody who stayed with us through any portion of today. Thank you so much for this. This is something that I had a lot of fun doing. We've been looking forward to doing this for a while. Despite our management giving us a hard time about different, like, why are you calling it Geek Edition and all that stuff? It's like, trust me, it's the Geek Edition. That's what this is focused on. But it's something that I think is a lot of fun. I get to play with 3D printers and toys and Lego and all this other stuff and actually claim that it's work. I mean, how could you not have fun with that, right? So again, thank you so much for sticking with us. And I do want you to try the poll. Apparently there is a poll that is part of MVA that should be, I believe, near the bottom of your screen or under the video that you can click on. Please like us, please. It's sort of like all those requests you get from unnamed large social network that people are like, please like me on this unnamed large social network. It sounds sort of like, I'll be your best friend.
Like us in the survey.
Yeah. So, but please like us on that, rate us highly if you thought highly. And if you thought this was terrible, please certainly let us know that as well. So thanks again. And if there are topics that sort of along the same vein that you want to see from us in the future, please let us know. You're at Boy of Green on Twitter.
That's right.
I am at Pete_Brown, and we're definitely interested in other things that you folks might want to learn about. So thank you, and enjoy the rest of your day, night, evening, whatever's left.